There is no specific National Electrical Code (NEC) requirement for the height of ground fault circuit interrupter (GFCI) protected outlets installed in a maintenance garage that is primarily used for motor equipment storage. The NEC provides guidelines for the installation of electrical systems to ensure safety, but it does not typically specify mounting heights for receptacles unless related to accessibility requirements such as those found in the Americans with Disabilities Act (ADA) standards, which might apply in certain public or commercial settings but generally not in a private maintenance garage. However, several factors should be considered when determining the appropriate height for GFCI outlets in such a space. Firstly, practical considerations are essential. The height of the outlet should be convenient for the intended use, allowing easy access for plugging in power tools, equipment chargers, and other devices without causing undue strain or requiring excessive bending. A common practice is to install receptacles at a height of around 12 to 18 inches above the floor, which is a standard height for many residential and commercial applications. Secondly, safety is paramount. The outlet should be positioned to minimize the risk of physical damage from equipment or vehicles moving within the garage. They should also be protected from potential water damage, especially if the garage floor is frequently washed or exposed to moisture. If there is a risk of flooding or standing water, the outlet should be mounted higher to prevent submersion. Thirdly, local codes and regulations should be taken into account. While the NEC does not specify a height requirement, local building codes or electrical ordinances might have specific rules regarding receptacle placement. It is important to consult with the local building department or a qualified electrician to ensure compliance with all applicable regulations. Fourthly, GFCI protection is crucial in a maintenance garage environment. GFCI outlets are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. This is particularly important in areas where there is a higher risk of moisture or dampness, such as a garage. The NEC requires GFCI protection for receptacles in certain locations, including garages, to enhance safety. Fifthly, consider the specific equipment that will be used in the garage. If certain tools or equipment have specific power requirements or cord lengths, the outlet placement should accommodate these needs. For example, if heavy-duty equipment with short cords is used, the outlet should be positioned close to where the equipment will be operated. Sixthly, proper wiring and installation are essential. All electrical work should be performed by a qualified electrician who is familiar with the NEC and local codes. The wiring should be properly sized for the intended load, and the outlet should be securely mounted to prevent them from becoming loose or damaged. Seventhly, regular inspections and maintenance are important to ensure the continued safety and functionality of the electrical system. Outlets should be checked periodically for damage or wear, and GFCI devices should be tested regularly to verify that they are functioning correctly. Eighthly, it is advisable to consider future needs when planning the outlet placement. Adding extra outlets at strategic locations can provide flexibility and convenience as the garage is used over time. This can help avoid the need for extension cords or power strips, which can create safety hazards. Ninthly, ensure that all electrical work complies with the NEC Article 210.8, which covers GFCI protection requirements for dwelling units and other locations. While a maintenance garage might not be a dwelling unit, the principles of GFCI protection are still applicable for safety reasons. Tenthly, consider using weather-resistant (WR) receptacles if the garage is exposed to moisture or dampness. These receptacles are designed to withstand harsh environments and provide added protection against corrosion and electrical shock. In summary, while there is no specific NEC height requirement for GFCI outlets in a maintenance garage used for motor equipment storage, careful consideration should be given to practical needs, safety, local codes, and the specific equipment that will be used. Consulting with a qualified electrician is always recommended to ensure compliance with all applicable regulations and to create a safe and functional electrical system. The absence of a specific height requirement provides flexibility in designing the electrical layout, but it also places a greater responsibility on the installer to ensure that the outlets are placed in a manner that maximizes safety and convenience. Remember to prioritize safety above all else and to follow best practices for electrical installation. Furthermore, it's essential to understand the broader context of electrical safety within a maintenance garage environment. Garages often present unique challenges due to the presence of flammable liquids, tools, and equipment that can increase the risk of electrical hazards. Therefore, adhering to all relevant codes and standards is crucial. Additionally, consider the following points to enhance safety. Firstly, ensure proper grounding. A properly grounded electrical system is essential for preventing electrical shock and minimizing the risk of fire. All outlets, equipment, and metal enclosures should be grounded according to the NEC requirements. Secondly, use arc fault circuit interrupters, the SIs, in addition to GFCIs. SIs provide protection against arc faults, which are a common cause of electrical fires. While SIs are typically required in dwelling units, they can also provide an added layer of protection in a garage environment. Thirdly, keep electrical panels and outlets clear. Avoid storing items in front of electrical panels or blocking access to outlets. This ensures that electrical equipment can be easily accessed for maintenance or in case of an emergency. Fourthly, use appropriate extension cords. When using extension cords, choose cords that are rated for the intended use and are of the appropriate gauge for the electrical load. Avoid using damaged or frayed extension cords, as they can pose a serious safety hazard. Fifthly, implement a lockout/tagout procedure. When performing maintenance or repairs on electrical equipment, follow a lockout/tagout procedure to ensure that the equipment is de-energized and cannot be accidentally turned on. Sixthly, provide adequate lighting. Ensure that the garage is adequately lit to prevent accidents and to make it easier to work on equipment. Use energy-efficient LED lighting to reduce energy consumption and to provide bright, even illumination. Seventhly, regularly inspect electrical equipment. Periodically inspect all electrical equipment for signs of damage or wear. Replace any damaged equipment immediately to prevent electrical hazards. Eighthly, educate users on electrical safety. Provide training to all users of the garage on basic electrical safety principles and procedures. This can help prevent accidents and ensure that everyone is aware of the potential hazards. Ninthly, consider installing a surge protector. A surge protector can protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. This can help prevent damage to expensive tools and equipment. Tenthly, maintain a clean and organized workspace. A clean and organized workspace reduces the risk of accidents and makes it easier to identify potential hazards. Keep tools and equipment properly stored and avoid cluttering the garage with unnecessary items. In conclusion, while the absence of a specific height requirement for GFCI outlets in a maintenance garage provides some flexibility, it is essential to prioritize safety and to follow all applicable codes and standards. By considering the factors outlined above and by consulting with a qualified electrician, one can create a safe and functional electrical system that meets the needs of the garage users. Always remember that electrical safety is a shared responsibility, and everyone should be aware of the potential hazards and take steps to prevent accidents. Furthermore, it's important to understand the long-term implications of electrical installations in a maintenance garage. Over time, the electrical needs of the garage may change, and it's essential to design the system with flexibility in mind. Firstly, consider the potential for future expansion. Plan the electrical system with the potential for future expansion in mind. This may involve installing additional conduit or wiring to accommodate new equipment or tools. Secondly, use durable and corrosion-resistant materials. Maintenance garages can be harsh environments, so it's essential to use durable and corrosion-resistant materials for all electrical installations. This will help ensure that the system lasts for many years without requiring frequent repairs or replacements. Thirdly, implement a preventive maintenance program. Establish a preventive maintenance program to regularly inspect and test the electrical system. This can help identify potential problems before they become major issues and can extend the life of the system. Fourthly, keep accurate records of all electrical work. Maintain accurate records of all electrical work performed in the garage, including wiring diagrams, equipment specifications, and inspection reports. This information can be valuable for future maintenance and troubleshooting. Fifthly, stay up to date on electrical codes and standards. Electrical codes and standards are constantly evolving, so it's essential to stay up to date on the latest requirements. This will help ensure that the electrical system remains safe and compliant over time. Sixthly, consider energy efficiency. Implement energy-efficient lighting and equipment to reduce energy consumption and lower utility bills. This can also help reduce the environmental impact of the garage. Seventhly, provide adequate ventilation. Ensure that the garage is adequately ventilated to prevent the buildup of fumes or gases from vehicles or equipment. This is especially important in enclosed garages. Eighthly, install a fire suppression system. Consider installing a fire suppression system to protect the garage and its contents from fire. This can help minimize damage and prevent injuries in the event of a fire. Ninthly, use tamper-resistant receptacles. Tamper-resistant receptacles can help prevent children from inserting objects into the outlets, reducing the risk of electrical shock. Tenthly, ensure proper labeling of circuits. Clearly label all circuits in the electrical panel to make it easier to identify and troubleshoot electrical problems. In conclusion, designing and maintaining a safe and functional electrical system in a maintenance garage requires careful planning, attention to detail, and a commitment to following all applicable codes and standards. By considering the factors outlined above, one can create a system that meets the needs of the garage users and protects against electrical hazards. Always remember that electrical safety is a continuous process, and it's essential to stay vigilant and to take steps to prevent accidents.